name is Kasper Jablonski. I have been working at Alterdata for over 3 years. I started as a data engineer. Currently, I lead the data consulting area, which means I help our clients build and develop cloud analytics platforms. First, I would like to ask you something. That is, who among you can't wait to get back to work and apply some of these ideas to a new project or a new integration? I see one hand up, I see another hand. I see more and more hands. Some of you have raised your hands. I'm very pleased about that. Some of you didn't. And I hope it's because you'd like to use these ideas to improve something that already exists, rather than necessarily creating something new. And that's exactly what I'd like to talk about. That is about how at the right scale, it's sometimes worth considering whether instead of creating something new, we should just improve something that already exists. And maybe this refactoring can actually bring greater business value to our users. Good enough, meaning sufficiently good. This is a phrase that I think sometimes guides us. For people who work in IT, that is, it's a phrase that works very well when we want to build a POC to verify a hypothesis. But very often it happens that, unfortunately, because we have to do such things quickly and efficiently, what was initially supposed to be just a POC and hypothesis verification ends up in production. And then there's no time to go back and fix it. And in this way, our famous technical debt builds up. It's not a bad approach, but sometimes there comes a moment when it might be worth stopping and considering whether, instead of creating more new integrations, we could somehow improve the ones that already exist. And when I hear the phrase good enough, it reminds me of a quote from the movie Whiplash, where the character Fletcher, the music teacher played by J.K. Simmons, says that there are no words more harmful in the English language than good job. And while I don't quite resonate with the drama in that statement, I do agree with Fletcher that we should always remember that we can do things more efficiently, more precisely, faster, and simply better. And now moving on to a specific case. We have been working for several years with a company called Generate Capital. This is an American company, currently with a few hundred employees. Kamil already mentioned it briefly in the introduction. They are involved in the broadly defined renewable energy sector and everything related to it. This means both building infrastructure, including batteries and solar panels, managing projects, managing financing projects, and generally asset management. At this point, they are quite a large company. And at some point, they set a goal to create a modern, secure, cloud-based analytical platform that would be able to support all business departments. As you can imagine, this is not an easy task. One of the challenges is that they have a lot of data. That is, besides the obvious sources we encounter when working in other industries such as ERP or CRM systems, they also use planning or predictive data, which change every day. So both the volume and the number of these data are very large. They approached us because they had a relatively small implementation team, and it would have been difficult for them to achieve the goal they set for themselves on their own. Also because building such an analytical platform, as I hope you gathered from yesterday's or today's lectures, is not a task that always requires the same skills. These are skills that change over time. And that's exactly how our collaboration with Generate Capital looks like. That is, we started with simple data engineering support. At the peak, let's say, at the very peak, we had 11 people on this project simultaneously, some of whom were indeed data engineers, but also analysts and architects. In fact, I once made a summary and found that over half of our company was somehow working on or involved in this project. And just some time ago, such a situation occurred. This is a fragment of the old architecture that I wanted to show you, where the data team from Generate Capital went to the business side and started discussing their pain points. And it quickly turned out that it's not that they are bothered by not having access to new data sources, but rather that the access to the data sources they already have is inefficient. This fragment, which you see here, fits very well into this diagram that was shown yesterday on several slides, where on the left side we have the data sources. In this case, we have, for example, a CRM system in the form of Salesforce and an ERP system in the form of Business Central. This is a Microsoft tool. Additionally, there is another source in the form of a system with planning and predictive data. Next, we have a part of the architecture responsible for pulling all this data into the warehouse. So going back to the diagram from yesterday, ETL or ELT processes. In this case, we have, for example, Python code. From this specific source, we pull data using Python code hosted on a virtual machine that is deployed in Azure. As for the ERP and CRM systems, we use a tool called StreamSets for this. Then all this data is loaded into the warehouse. The warehouse is in Snowflake. We won't be dealing with this part. The warehouse in Snowflake is used all the time. Regarding the orchestration of these processes, until now, it has been Randeck. This is also a tool that is quite rarely seen on the Polish market, but it exists. With this architecture, at first glance, there were really no problems, right? That is, on one hand, we have these data sources, and on the other hand, we have a business need for this data to land in the data warehouse. But if we take a closer look, it turns out that it doesn't work quite well. That is, if we look at this process here, it turns out that the volume of data being loaded once a day is very large, which means that a single loading process takes 20 hours. If everything goes well, then of course, 20 hours it's tough, but we have the data in the warehouse, everything is okay. If this process crashes, for example, halfway through and we need to reload the data again, then we already have a delay of 20 hours and we will only have the freshest data the next day. This is the first problem. The second problem is that, in reality, even though we are using a fairly flexible tool like Python, because it doesn't take advantage of all the benefits provided by the cloud environment, specifically the whole serverless approach that Adam talked about, managing this process requires a lot of manual work. This means that instead of using some kind of serverless service, we are simply running this Python code on a virtual machine. And this virtual machine has exactly the same issues as any server we use. So, for example, the disk space might run out, the memory might be exhausted, or the processor might be overworked. And while we do have the ability to scale it up, it is simply time-consuming and problematic. The third issue is that, as you might remember from Adam's presentation yesterday, certainly dedicated ETL tools have their advantages. That is, when we have a workload that requires a one-time data transfer, at this moment, then indeed using such a dedicated tool will be the simplest solution. StreamSets is exactly such a tool where we can simply create a pipeline that transfers data from one place to another. But in the long run, it may quickly turn out that these types of tools, despite being easy to use, generate very high costs. And that's exactly the case with StreamSets. This tool works and is quite good, but it has rather high licensing costs, which is why the entire workload related to extracting data from the ERP and CRM systems was very expensive. In connection with this, we all came up with the idea to streamline this process a bit. I will soon talk about how our approach to this improvement process looked in general, but I would like to show you what this architecture looks like at this moment. In fact, well, at first glance, not much has changed because the entire logic remained more or less the same. That is, we still have the sources on the left side. We have some processes that extract this data. And in the end, it all lands in Snowflake. So theoretically, not much has changed. In practice, a lot has changed. On one hand, what we did was rewrite all these integrations into our own custom Python code. Secondly, we also introduced an improvement in the form of a new file format, which is perfect for handling such a large volume of data, like the volume coming from this planning system. To answer, it is the Parquet data format. The third point is utilizing all the benefits that the cloud offers us. This means that instead of deploying this Python code on virtual machines, which we have to manage manually, we used an Azure serverless service based on containers, Azure container instances. As a result, the entire overhead associated with manually maintaining this Python code has practically been eliminated. The business benefits were visible almost immediately. That is, firstly, all these data loading processes started to occur much faster. We went from 20 hours down to a few in the case of the heaviest workload. Secondly, the entire system turned out to be much simpler to maintain. That is, firstly, we streamlined the entire process because we use only one tool, which simply makes it easier to maintain. Secondly, because we use this serverless, it also eliminates all tasks related to manually maintaining the engine that runs all this code. Thirdly, we also delved deeper into Azure, right? Instead of paying licensing costs to various vendors, we focused solely on Azure. As a result, we also replaced the orchestration tool from Rundeck to Azure Data Factory, which is natively available in Azure. And this ultimately reduced costs as well. So, yes. How did it go? Does anyone have any questions about this part? Is anyone interested in something? All right, I'll continue. How did we approach the process of, first of all, identifying the areas where improvements would be beneficial, and then the process of implementing those improvements? So, first, we decided to find, I would like to say quick wins, but they weren't exactly quick wins, because none of them were quick, but they were wins. Generally, these were areas where we could achieve the greatest value with relatively little effort. And that's how we chose these three data sources that we worked with. And then for each of these sources, we conducted refactoring processes. We called them migrations. What we did first was simply write the code. We rewrote this code in Python, but writing the integration itself, let's say, is the simplest task in all of this. What was the most difficult for each of them was ensuring that the new data landing in this system did not disrupt what we previously had in the reports. So in the case of each of these migrations, what was truly the most time-consuming was ensuring that with our new method of importing this data, we weren't breaking anything in the existing reports. That's why I would like to present to you a set of tips and some of our observations that come from these three migrations we conducted. They all took place at different times, and we also had some time after each of them to reflect, conduct some self-reflection on what we could have done better. And I Can also proudly say that each subsequent migration went much more smoothly. What we did before the migration, before each of them, what is definitely worth doing is to thoroughly think through the strategy. That means writing down step by step what is supposed to happen, in what order, literally. We certainly won't foresee everything, and there will definitely be some things that we overlook. But thanks to having some sort of step-by-step plan from the very beginning that we would follow, we were able to verify whether our migration was proceeding correctly. And also, from migration to migration, our plan became more precise because it was simply supported by our past experience. It's definitely worth spending some time identifying risks. This is, of course, something that naturally comes up during such planning, during the preparation of such a strategy. It's also known that there are some things we won't foresee, but we can certainly minimize potential risks. Prepare a POC. In the case of each of these migrations, we definitely spent some time verifying certain hypotheses. This means that we didn't proceed with the entire migration process until we were sure that we had a small piece of code that, for example, extracts data from just one table. Because the information that comes from such a small POC is essentially priceless, and a large part of the risk associated with a full-scale implementation can definitely be mitigated. Regarding the QA process itself, as I mentioned, the biggest challenge was that, for example, in the case of one of these sources, we had hundreds of tables that we had to test in the same way. And to put all of this into production and ensure that we do it correctly and check each table in the same way, we prepared a step-by-step guide on what to do to verify it. Thanks to this, when we decided that, for example, we had too few people on the project to handle everything on time, bringing in additional people was straightforward because we had a ready-made guide that we simply gave to the new person. And without a special onboarding process, they could start helping us. Regarding what happened during the migration, as I mentioned, the main challenge was the QA process. What is certainly important is that our guide, which we created, and the plan we developed before the migration were continuously updated. This means that practically every day, something new would come up that we realized needed attention or an additional step that was necessary in our guide. We continuously updated and added to everything, and thanks to that, it was alive and truly useful. Prioritization, what is important and what is not. This might also serve as more of a warning, because it's clear that every such refactoring involves doing some things differently. It may turn out that for some reason suddenly this QA, meaning the tests we conduct to compare whether our old reports and new reports match, it simply works. It may turn out that the data we receive differs, but that's not a problem for us at all. And it's also worth being aware that this can simply happen. For example, I remember exactly that. For one of these sources, we started extracting data using this new method, meaning with Python. And we began comparing them, old reports to new ones, as apples to apples. Theoretically, everything should have matched, but everything was off. That is, all the values in the column with a specific measure were off. And when we looked into it, it turned out that they were off because the new data had much greater accuracy. They were simply much better than the old ones. As a result, it turned out that for several years, users were working with inaccurate data. Scaling the team and resources also requires having an open mind and being cautious and attentive to situations where the resources we currently have may simply not be enough for what needs to be done. As I mentioned earlier, we had around several hundred tables to process, and it quickly became apparent that with the number of people we have, we simply wouldn't manage. And also, thanks to having this strategy and plan so well thought out, we were able to easily onboard additional people, and with a slight delay, we managed to get it done. When it comes to automation, it's also worth considering whether something can be improved. That is, as I mentioned earlier, we had several hundred tables to check. Probably some people here had the question pop into their heads whether something could have been automated. Indeed, it was possible, and where there was room for it, we certainly implemented some level of automation for those tests. Regarding what happened after the migration, I am generally a person who strongly believes in feedback in general and in self-reflection. I really like the concept of lessons learned. After each of these migrations, we would meet with the entire team and discuss what went well and what, in our opinion, could have gone better. After each of these sessions, we would come to some conclusions, and that's why each subsequent migration went increasingly better. So I'm very pleased as well. Of course, after each of these migrations, we monitored our solution, meaning whether week by week the data still aligns and whether the business can trust it. And certainly another aspect is that during the first step, I mentioned earlier, which is preparing the plan, the strategy, it's worth considering the steps that will need to be taken after the migration itself, such as cleaning up those old processes or any cleanups that are necessary, and so on and so forth. Of course, this is all case by case. And now, to not just talk without evidence, I took the liberty of pulling a few quotes from what our client wrote after one of these successful migrations, because I think that resonates most with someone working in IT. When what we do has an actual embodiment in the business, meaning when end users come to us and talk about how what we did has truly impacted how they work. And just like I mentioned earlier, the entire overhead related to manually maintaining those VMs has absolutely disappeared. And it has truly happened to the extent that it even affected the morale of the entire data team on the client side. We absolutely managed to shorten the time. Here is an interesting case that I didn't mention earlier, but it's something Adam talked about yesterday. On one hand, we have these dedicated ETL tools, and they are indeed great because they allow us to quickly transfer data from one place to another. But we all know that life is never that simple, and very often we have to handle some edge cases, some corner cases, and using custom functions written in Python provides the ability to work around these cases with minimal effort. And that's exactly how it was in this case. By transitioning and migrating to Python, we gained this flexibility. Savings came in the form of not needing licenses, because previously they were using tools from a third-party vendor, namely StreamSets and Rundeck. And as I mentioned earlier, the team also worked much better with this new stack. So they were simply happier. And finally, some golden thoughts that I added. Of course, it's not like everyone can afford to reduce technical debt on an ongoing basis. And I also know from experience that when we seek funding for an IT project, reducing technical debt is something that very rarely brings that tangible business benefit. But maybe indeed, maybe in our case, that's how it is. That's why sometimes it's worth considering instead of adding another new piece to the puzzle. And maybe it's worth considering whether something can be optimized. Similarly, there is no perfect moment for optimization, for modernization, for optimization. Well, you just have to sense it. We happen to be in the comfortable situation of having a discussion partner in the form of this client and their data team, as both sides saw that some elements of the old stack simply weren't working. So when we were talking with the business side, on their end, it was simply easier for us. And one last golden thought is that the migration process itself can also be improved. That is, not to close ourselves off and assume that what we've come up with is the best, but to have an iterative approach. And I'm very pleased that each of the migrations we conducted was simply more effective. Each one went faster, and after each one we had less to correct. And that's basically it. Are there any questions?
There is no audience. So maybe I'll ask, continuing this journey across the Atlantic, are there any practices regarding American market clients that we could transfer to the Polish market? Good practices to implement? Or is there nothing like that, something we can learn from? Or are they doing things more innovatively, faster, better?
Not really. I mean, what was definitely interesting there was that they actually use sometimes slightly different tools than we do. And for example, we indeed came across some tools there that we hadn't encountered in any other project. It's also an interesting fact that at this point, probably everyone knows and associates DBT, and generally such data transformation tools like DataFarm or DBT. This was our first project where we encountered this tool. And at this point, I don't think there's any project at Alterdata that doesn't use this tool. That's an interesting fact. So as for practices, probably not. On the other hand, we also opened their eyes to some things.
Great. Questions?
I still have a question, because in optimizations, cost reduction is always an important aspect. You mentioned licenses, but I also remember that in this project with Snowflake and in others based on different warehouses, there are significant changes in the expenses for the warehouse itself, for example. There were such cases too, from what I remember.
Yes, absolutely. In the sense that what you're talking about was a somewhat separate, slightly different project, but we also did such things, meaning we also conducted purely optimization projects. Until now, they operated well, because by working with Snowflake, they are working in Azure, but they operated in a somewhat unaware manner. That is, if they needed something, they would just take it. But when we started working with them, we systematically sit down to each subsequent element of this puzzle and optimize step by step. And precisely one thing was the optimization of Snowflake, which you just mentioned. Recently, we have been working on, for example, optimizing Azure costs, specifically Azure storage. And we have already done a first mini implementation there, and it works and also brings real optimizations. Savings, that's the word I was missing. Is there perhaps any other question?
Thank you, Kaz. And I would like to say to everyone, I see a question.
Yes, I wanted to ask, why specifically Parquet files and not, for example, Avro? And does it have any connection with optimization, like reading something, columnar database, and so on and so forth?
That's a good question, one that I certainly won't fully answer, and it might be best if we discuss it later in private, because to determine that, Parquet files would work best for us in this case. We conducted a mini proof of concept where we tried different approaches. From what I remember, I don't think we tested Avro at that time. There are definitely, There's an enormous amount of this data. There are an enormous number of rows. So Parquet worked because the columnar compression worked well in this specific case. Did we test Avro? I don't remember. Okay, but what we had before were just pandas data frames. So that didn't work at all. Any more questions? All right.
Thanks, Kasper.
Thank you.